Now we will define how to find the inverse of a matrix. So this is a matrix whose entries are 4, 7, 2 and 6, and we want to find the inverse of this matrix. So uh, notation or symbolically it can be written as minus, means above the square brackets. When we close this square brackets, we write over here -1, which means that we are doing to find the inverse of this matrix. Okay, so if you want to find the inverse of a matrix, you need two things. The first is you want to find the adjoint, and the second is you will find the determinant. It's okay. So adjoint over determinant is actually the inverse of a matrix. So first of all, what is adjoint? Adjoint is you will change the position of 4 and 6. Okay, when you will change the position of 4 and 6, then it means that 4 will take the place of 6 and 6 will take the place of 4. Okay, so shift 6 from here to here means in place of 4, and shift 4 in place of 6, just like as. And the second is you will change the sign of 7 and 2. You will not change the position of 7 and 2, you will just change the sign. Since it is +7, so after changing the sign it will be -7, and it is +2, after changing the sign it will be -2. Okay, so this is. And what is the determinant of this matrix? You know, determinant is actually the multiplication, cross multiplication of 4 and 6 and 7 and 2. 4 multiplied by 6 it is 24, minus 7 multiplied by 2 it is 14. Okay, so 24 minus 14 is 10. Okay, and you know, this is the adjoint divided by determinant, which is called inverse of a matrix. So when you will divide 6 by 10 it will be 0.6, and when you will divide -7 by 10 it will be -0.7, and when you will divide -2 divided by 10 it will be -0.2, and when you will divide 4 by 10 it will be 0.4. Okay, so this is the way how to find the inverse of a matrix. Okay, now we discuss about after inverse, sorry, Cramer rules. These are two equations. These equations are called simultaneous linear equation. Cramer rules actually work to find the solution of simultaneous linear equation. First of all, you have to understand that what does it mean by solution. Solution always means that you want to find the values of unknown variables. So what are the unknown variables in these simultaneous linear equations? Here x and y are the unknown variables. Okay, and the coefficient of these variables are a, b, c and d, and these are two constant e and f are constant. So if you want to find the value of these variables, means x and y, then what is the Cramer rule? Cramer rules help you to find the values of x and y, just like as x is equal to, you will write EF. A, B, C and D are the coefficients. Okay, and the matrix, of course it will be A, B, C and D, one matrix. It's okay, but here what you will do, when you will find the value of x, you will not write A and C, you will write E and F in place of A and C. You can see over here, we are not writing A and C over here, we are writing A and F, and then it is B and D, B and D, and in the denominator you will write the determinant of the matrix A, B, C and D. Okay, either you are finding the value of x, either you are finding the value of y. And when you will find the value of y, then what you will do, you will write not b and d, you will write over here e and f, and in the denominator as it is in x, a b c d. So it means that either you are finding the value of x, either you are finding the value of y. In both, you write the determinant in the numerator and in the denominator. Okay, the denominator determinant is same, a b c d, a b c d. The denominator determinant is same, but nominator determinant is different. How it is different? When you will find the value of x, you will write e and f over a and c in place of a and c, and when you will find the value of y, then you will write e and f in place of b and d. Okay, e and f in place of d. So this is the way how to find the value of x and y, unknown variables, by using the Cramer rule. Let me discuss an example. This is an example. In this example, you can see that 3x plus 2y minus z is equal to 1, x minus y plus 5z is equal to minus 2, 2x plus y is equal to 3. So these are simultaneous linear equations in three variables, x, y and z. Okay, what are the coefficient of these variables? In the first equation it is 3, 2, minus 1. Okay, and in the second equation it is 1, minus 1 and 5, and here 2, 1, and since z is missing, then it means that coefficient of z in this equation, third equation, is 0. And what are constant? 1, minus 2 and 3. As we have described the Cramer rule before, when you will find x, then what you will do? You will write the determinant in three cases. Determinant of a when you will find x, determinant of a when you will find y, determinant of a when you find z. So the difference is only on the nominator, not in the denominator. The difference is only in the nominator determinant. Okay, how it is? Just like when you will find x, the matrix is 3, 1 in first row, 3, 1, 2. You will not write in the first row 3, 1, 2. You will write 1, minus 2 and 3. Yes, 1, minus 2 and 3, and the remaining row will be same, 2, minus 1 and 1, minus 1, 5 and 0. Okay, these are sames. Okay, and here determinant of a, so it is 24 divided by 2, which is equal to 12. And when you will find the value of y, then it means that you will not write 2, minus 1 and 1. What you will write? You will write the value of 1, minus 2 and 3. Yes, 1, minus 2 and 3. And when you will find the value of z, you will not write minus 1, 5 and 0. You will write 1, minus 2 and 3 over here, 1, minus 2 and. So what is the determinant of this? As you have already find the procedure of determinant, which is 24 divided by 2, and this determinant is minus 42 divided by 2, which is minus 21, and this determinant is minus 14 divided by 2, which is equal to minus 7. So the values of x is equal to 12, y is equal to minus 20, and z is equal to minus 7. So this is the way how to find the value of x, y and z by using the Cramer rule. It's okay. See you in the next lecture.